So it's been a while since I had a chance to make a video. So while I was browsing the internet, I ran across a video from Dave Jones on the EEV blog talking about a kind of generic automatic component tester. You take anything off the bench, throw it into it, push a button, and it automatically figures out exactly what the component is and its relative values within, reasonable accuracy. And it all does it with the help of an Atmega 328P, which is the exact same processor, that goes into essentially every Arduino. Practically every Arduino, I guess, anymore. But so I went on eBay, looked around, and I found a neat little kit. I'll link it down below from the seller I bought it from. Not advertising for him or anything, just the one I got. It comes as a kit, which you build yourself. Comes with a nice PCB, and then I also made sure I got the version that came with the Lexan case, just to have. So I'm going to go through this build video, kind of not step by step, but I'll give you the general rundown. Mostly because of the seller had all the build instructions on their description, linked to some kind of online file sharing site, but unfortunately when I went and bought it, that site was reached its capacity, so I had to email the seller, and they were nice enough to just directly send me the PDFs for them. And I figured I'll just give you a rundown of what the build's like, because it's not too difficult putting it together. As you can see, a whole bunch of metal film resistors, select few capacitors, a couple little transistors and a voltage reference, and like big components like the display, encoders, connectors, stuff like that. Fortunately, this one though does have three very, very, very small components. This is a little SOT23. These are Esd Protection Components. So this is a diode array, and this is a transient suppressor diode, and this is, I think, just a small surface mount capacitor. I'm not sure what they're using that for. And they all go right down here. They seem like a little bit of an afterthought since they're just kind of slapped in. They're the only surface mount components on there. They're probably really the only options actually for that kind of stuff anymore. But so I'm going to be soldering those in first, and then I'll start tackling the resistors. So I'm going to skip ahead, go through the soldering. I won't bother boring you with that kind of stuff. For those who are curious, I am using my genuine Hako 936 with the standard tip actually on it. I've never changed it. And just some standard 6040 solder and nice flux pen. So I'm going to go right through it and lickety split. So I'm going to put those surface mounts on there, and I'll be right back. Okay, now we got those three little guys right there down at the bottom all soldered in. I also took the liberty to take some flux remover, as was suggested in the instructions. I'm not sure how much that would actually throw off accuracy, but might as well make it look nice. So okay, now I'm going to go through the metal film resistors all over the place, and the silk screen is kind of nice because they do label values like that, so it should be just pop them in, solder them, trim them off, and away we go. So let's get some resistors in there. Okay, so with all the resistors on there, quite a bit of them, but I'll wash down the board after I get everything else soldered in. So next up then, we got a whole pile of ceramic caps and a couple of electrolytics, and they just pop right into the board exactly where the silk screen. So I got a couple 22 picofarads up there, a couple 104s, that must be 40, so 1000 picofarads, no, 10,000 picofarads. And electrolytics like this one here are clearly marked which side's positive and which side's negative. So we'll go start slapping those caps in, and we'll get on to the major active components. Okay, with all the caps in, not too hard. I was left over with one extra cap, which the part sheet says is actually 100 nanofarad. So, oh well. I got all the resistors came out to the exact amount, even with the several individual values and stuff like that, so it's not too bad. So the next step then I'm going to be putting in is the LED, the crystal, and then there's a couple NPN transistors, and then I think a PNP, and then a voltage reference, which is the heart of those whole system, and also a little voltage regulator. So those are all actually pretty clearly laid out on the sheet as well. So this guy right down here is the TL431. That's our voltage reference. So just start slapping those in just like the rest of them, solder them up, and we're ready to go. Okay. Alright, now with all of our last active components, really, those we got left are things like the connectors, our nice little fancy connector here guy, and the Atmega. Unfortunately, this seller decided to take what I assumed is a pre-programmed Atmega and just sellotape it to the socket, which protects the pins, but there's no way to take this tape off without producing a huge amount of static electricity, and I doubt this is any kind of fancy anti-static tape. So if the Atmega survives, which, I mean, theoretically it does have Esd protection, so well, we'll find out. We'll see how good it is, but we're going to do the rest of it and then put like the encoder into it, which is a nice push button encoder, which is fancy, and the extra power jack with the 9-volt connector. Put all those in there so they're not too difficult to put in there, and and then we'll get to the final steps of actually plugging stuff in and try and figure out how to get that case together, because although it has reasonably detailed instructions on how to assemble it for this circuit, it has no instructions whatsoever for the case. So that's going to be a different matter. But all right, so let's slap in all those connectors real quick. Okay, making progress. So all the connectors are soldered in. I took liberty and slapped in the Atmega, the EEPROM programmer, which has been repurposed as the connectors on there, and I got my encoder installed too. I did wash the whole board, cleaned it up, except for the encoder. The instructions were very explicit about saying the encoder and the display module won't take kindly to doing solder flux cleaning, so I'm gonna just leave the flux on that. It's not gonna matter for the measurements. Only the digital signals are gonna be going through that, so whatever. Now I got a couple of metal standoffs and screws in order to get the display module in, since there's these half moon cutouts over here, which line up with these two holes in the board, and then two standoffs, and then the two screws hold the one side of it. Now the kit also included a whole bunch of other standoffs and screws, and those were intended to go around the corners to give it someplace to just sit it on. But the case, I think, has standoffs for itself, so I'm not going to install the ones that come with the board. I'm going to be using the ones that come with the kit, and we'll figure out how this thing goes together afterwards. So put the display on right now. Okay, now we're into uncharted territory, and we're going to have to figure out how this goes together. Going to be interesting. So this looks like all laser cut Lexan, 1/8 inch, 1/4 inch, 1/8 inch thickness, something like that, close enough. Bunch of standoffs and screws. I'm also going off one of the pictures from the sale, but the sale is definitely looks like a different case, because it has plastic standoffs and very long screws, where this one has well, I guess very long standoffs and metals. It might work out still the same. So I'm going to assume this is the top, which, yeah, lines up with it pretty well. Gives us access to the all four corners of the screws. And these slots must be holding in the side panels, and then this nice long side in order to get to the arm, which, well, we'll see how far this goes down. This only goes down like this far, then it's going to be hard to get to that lever. Well, we'll see. So the longer that lever is, so getting it, that might suck. And it blocks the surface mount connector, the test points too, so might not be an ideal case. To the bottom, guessing by it, looks like it. So, why do we have this then? Okay, why do we have to have two? Is this intended to go here, and then this is intended to go over top? And then this is intended to go over top of all this. Okay, well, that's elaborate. In order to protect the screen, so we have a Lexian all over the screen then. So these must be the two sides, so it must be angled so you can get access to it. Must be, for, you know, ease of use such as that. So this must be, I guess this is the left and then this is the right, because this is probably the notch for the lever. Okay, so we can actually start putting this into the bottom here. So left and right, left and right. No. Oh, dirt. Okay. Yeah, must be like this. Well, it might not fit because of the protective paper over top of the Lexan, so I might have to take that off. Well, that one fits. This one doesn't. Huh. Yeah. Don't want to break it. But this side is actually from different material. Okay. So we'll see if that kind of fits-ish, maybe. Going to guess. What's with the hole then? What do you need the hole? Why would you need the hole? Oh, okay. The DC power jack, which is on the side. Okay, that's good. So I think we got where these are at, and I think this makes sense. Then, yeah. This must be the top. It's both bigger because of the slope, and this has only one cutout for the, I think the top part is the frequency counter, I think. And then the bottom one is both a voltage and function generator, or frequency, frequency generator. It's not actually a function generator, it just generates a simple clock. Then there's this one in the middle, because there should be like a battery compartment, I think. Which way would this make sense to go? It's probably going to be like this, because it probably needs a cutout for the standoffs for the screws going down through the case, I think. That probably makes sense. So I'm going to have to see how this fits in here. And this must fit into the back. Okay, yeah, so then this fits into here. And this fits in like this. These don't quite fit because of the paper. And this left side just doesn't want to fit at all. might just be because of the protective paper on it. Oh. Alright. Okay. Getting someplace. Getting someplace. No, don't come out. Stay. Alright. Yeah. Okay. Uh-huh. And then the bottom must go in. Fits that side, fits that side, fits that side. Oh, that's going to be tight. I don't know if that's going to fit. Without the paper, it might fit, but it's going to be tight. Okay. And then all this goes on top. So I assume they mean you to tuck the 9-volt battery underneath there. Keep it out of the way. There's no real fastening for the battery, so it's either just loose in there or you're expected to tape it down yourself or something like that. But it's supposed to be replaceable. That's the one downside of this case. I mean, it's supposed to come with the battery, but there's no way to get to the battery without disassembling the thing. Oh well. Might have been better off just to not bother with the case at all. But I'm going to put it together in the case because I bought it, and I'm not going to admit a mistake. So I'm going to take all the paper off of all the Lexan, and then we're going to try and see how much of this stuff we can get together. I'm going to do that off camera so it's not boring to watch. Okay, it took me a while to figure out. I think I know what's going on here. So the standoffs, it comes with 2 long standoffs here, and I already assumed that since these are threaded on one end and then, well, they're threaded on both ends, but one's male, one's female, and I assume that this side takes a nut, so kit came with some nuts, gave it 2 nuts, and I assume the long ones are on the high side, the back of the unit, and these extra long screws are to get through these 3 layers of cutouts that protect the screen. So that's probably a reasonable assumption. And then these medium-sized ones, there's only 2 of them, I assume, are the closer side, the low side. So probably they'll probably need just single screws, since it's only going through 1 layer of Lexan down here at the bottom, and then 2 nuts that hold it on the bottom. So then with that, then I assume, this is where it got a little bit confusing, but what I think you need to do is ignore the brass standoffs from the PCB kit, and but you will need this 4 screws, I think. And oh, now that I think about it, I don't think you need the screws at all. Well, we'll see here. I'm trying to wing it. And it comes with these standoffs that have the matching thread in, and I think this is how it's going to go. I think you're going to take these 4, and we're going to put them in to the board like this, in these 4 corners. Oop. Don't try and watch yourself through the camera. Just do it normally. So then the 2 mediums and then the 2 standard ones here. Oops. These don't have to be cranked down hard. They're not going anywhere. They're going to be mildly portable. Essentially just portable around the bench. Not really intended to be thrown into a kit and wandered around the world or anything like that. So that gives us our nice little angled stand up to make the display slightly more readable when you're on the bench. Alright, so then with that, I think we can go safely right to the base. Can we safely go to the base? believe we should be able to safely go right to the base. So then we'll take our 4 nuts here and put them on. I guess you could actually use the 4 brass standoffs that came with it. That'd be a possibility too. Instead of using the nuts, you could use these standoffs if you want to have it a little bit higher up for some reason. Don't really know. Okay. Put these 4 guys in. They're not going to work great because the Lexan's at an angle. But that should actually be a little bit nicer because it will mean the nut will dig into at least one side of the Lexan. Let me get a pair of pliers here. The edge of the nut will dig into the Lexan, and then that will prevent it from really backing out much. Again, we don't need anything crazy here. It's only moving around the bench. It's not moving around the world. Okay, base, solid so far. All right. I guess I should have actually tried to see if this weird side panel actually fits into the base at all. Right. Oh, it's a tight fit, but it does fit. Okay. And it actually lines up with the DC jack, so that's a good start. Let's put the power cable underneath here. Let's work out where this one panel went. Where is it? Oh, the mid panel here. So we gotta figure out which orientation. Okay, the orientation has to be like this. So if this is the side, this is the left side here. You're gonna put this in like this. Then that means this has to go like this. Okay. And that means this side should just plop right into it. Come on. Oh, too many pieces here. It's just so tight because I think it's bumping against the screw that holding the display. Well, does it even fit outside of the case? Oh, come on. Come on. Yes, it does. See if we can coax it in this way. No, I'm not going to be able to because I need to get it down. Let's put this side in first and see if we can get it in the first. Yeah, I think that's what's going on. So I think this panel is just hitting the head of that screw. It's just slightly too far off. Oh, and you know what? Oh, jeez. I wonder, do I not have enough room here? Ah, shoot. Okay. I guess the wires for this 9-volt connector should have been coming out of the bottom rather than the top. Alright, I'll remount those. Clean that up then. I have to take it back out of the case in order to do that. Alright, a little bit of desoldering and resoldering. I'll do that quick. Okay, redid that so the wires are coming out the bottom. That leaves the edges of the board free of clutter. So let's try this all again. let's start with the DC jack side. We'll put the this mid board in here. Get in the slot. There we are. Okay. I'm going to leave the wire down below, so we should be able to. Oh, yeah, this is not gonna. I'll have to get the bottom in here first. These laser cut things are neat, but geez, they are fiddly to get together. Okay, now we're gonna take it like that. All right. Okay. Now we should be able to. I would say. I guess should probably put at least the front end then too, because that's probably going to get a lot more difficult to get in later. Okay, and the bottom. Let's get this mid board in. This thing is a pain in the neck. Alright, it's snapped in both top and bottom there. Yeah, I guess you just leave the battery floating around in there. I don't really want to tape it in or even bother with anything else. I'm gonna have to put it in now, actually, because I won't be able to. Once I get this side panel in, I can't get a battery through here, so it's going to have to come in now. Alright, first power up, see what it does. Guess I should have done this off camera. No time like the present. Okay, it does nothing. That might be normal. Maybe not. Maybe it just it's going to sit there and explode. Well, let's just try and turn it on. Hey, it gives me a... Yeah, sweet. No unknown or damaged part. Good. Guess we can leave that alone for now. Get back to it later. Oh, the LED works. So at least I soldered that in right. Oh man, that battery's gonna slide all around. Can't be put in like that, can it? No, there's not enough height to wedge it in like that. That would probably be better, but I'm gonna see. I don't want to use tape because that is always going to be semi-permanent. It will just never come off clean. So what I think I'm going to do, I'm going to grab some of that blue sticky tack stuff, put it a little bit on there, and just slap it onto the battery. At least that way it won't immediately fly around. Maybe on the bottom, actually, not on the front. Okay, I'm going to grab some of that from the kitchen. I'll be right back. Alright, this might seem a bit ghetto, but it seems to work. I was planning to use some of this little fun tack stuff, but I thought they almost had this. Okay, so this mid board, whatever, is angled compared to the base because the whole board, the whole standoffs make it all angled and stuff. It is just slightly too high. If it was extended probably a little bit longer, the battery might have been able to move around, but it wouldn't have been able to slide any farther. The battery is just, the standard 9 volt is just a little bit too narrow and will slide easily through there, so it can hit all the fun contacts down here. So I thought, well, I'll just wedge it in with some foam, and this is actually the foam that came protecting the connectors for the display. So I just took it and split it in half. The full piece is a little bit too thick, but split it in half and just wedge it in there, and now it can't fall out. It would pretty much have to fall down a flight of stairs in order for them to move the battery out of there, and that at least keeps it clean and stuff, and keeps it from, makes it a little bit easier to replace it, even though this is a nightmare to replace because you had to disassemble the whole case in order to get to the battery. So now that we got the two sides on, I should be able to get this front on, like so, if it'll cooperate, you can do it. This battery thing side doesn't want to cooperate. As soon as you do something, it likes to move. Try and get this side back in here. Come on, oh. Yeah. Just don't want to come. Okay, there. Ooh. Okay, so that's those. Let's try and get the back now. Let's see if this will fit. I actually didn't even try this side at all. No, pop right in. No, it didn't. There it did. Okay. Now we got the sides. DC barrel jack lines up reasonably. I was thinking about using a DC jack. If I try and do that, yeah, that should work fine. Yeah, for this one, it's not an exact fit, but it's one of those close enough things. So if you want to use the DC jack, that'd be fine. I'm gonna go with the battery just for now. See how long it lasts. If it dies, then I can use the DC jack. I wonder if you use the DC jack, there's probably no there's no diodes, so there's no isolation on the battery. So if you do plug in DC with the battery, it'll try and charge the battery, which will probably cause issues. Alkalines don't like that. Alright, okay. Now we got this menagerie of the top to try and figure out. Okay, this is I think the base plate for the whole top. So it should slide down. Which it does. Hey, good start. And no, the mid plate, which is just a spacer. It should slide down over top of these three. Which it does. Hey, oh, actually, now I think about it, I didn't take the protective film off the display. Let's do that now. Oh, that's not a protective film. No, it has to be the film remover removed itself, and not the display, because there's a quality stamp right in the middle of the display. I assume it has to be a film on here. Yeah, there's a film. Okay. A little bit of residue in the corner. Use the sticker to get itself off. Okay, good. I don't have a quality stamp right in the middle of the display, and that would suck. Oh, this there we go. Okay, that midboard likes to keep coming loose. All right. Okay, top display here. Good. The spacer. Okay. Then the top plate. All right. Okay, let's start screwing it together. I'm not going crazy yet. I'm just gonna get them all in before I tighten them down. Okay, so I don't want to screw these ones in the back too far because these standoffs aren't long enough. They're just like not even an eighth of an inch too short, so if you tighten them down too much, it's going to crack the Lexan. So we're just going to leave it slightly like that. These ones, though, these should be able to tighten down pretty good, or reasonable. It's just plastic. Okay. Hey, at least it looks reasonable. Oh, that's gonna suck. Yeah, that's... You can't actually tighten it down. Very unfortunate. I mean, you can do it with a screwdriver, which you need a screwdriver anyways to gain access to these screw terminals. So this is a voltage detector, so you can kind of use this as a very limited voltmeter. And this is the pulse width modulator generator. And I think one of these is input, one of these are output. I can't remember which. And, oh, right. It's still on. No or unknown component. Okay. At least it's still functional. Gives me a nice LED. At least partially functional. Not calibrated. For calibration, clamp the 3 pins together. Start with the key. Acknowledge the self-test with the key within 2 seconds. Disconnect pins after the message isolate probe is shown. Software and documentation is at SVN microcontroller/net transistor tester. Yes, excellent. So maybe in this menu someplace they might list what the software version is, and it might be possible to upgrade the version. I'm not sure how far off this hardware design is from whatever reference design that they run with. And it's not too hard to upgrade because it is just a raw Atmega 328. So I have a AVR ISP, so I can directly program those from whatever they got. Otherwise, it looks kind of neat, except for the janky battery holder. Yeah, it can move. Oh well. Set it down like that. All right. So I need to make a 3-point connector. I'm just going to grab 3 wires, solder them together, so then I can jam it in there and start this self-calibration. And I think it does need a capacitor, so I want to try and find a near enough value that it needs in order to do its self-calibration. Then we can start testing with the arrangement of components I can find laying around. Okay, so let's do that. Okay, so I got a little collection of components that we can try this thing out on. So one of the first things we're going to do is try and go through its self-calibration and stuff like that. So first we have to start with connecting all 3 connections together. So we can jam it in. Just can't quite get it in there. That sucks. The other thing I did is I also color-coded the test points. So these 3 over here are test point 1, this one in the middle is test point 2, and then these 3 over here are test point 3. Just to make it a little bit easier to know where I'm going, since it was all just a sea of blue. But anyways, let's push this guy. And let's see what he does. Self-test, yes. And he's going to do things. And isolate probes, which I think means disconnect everything. Just come up. Okay. And then it's also going to need a capacitor. And the directions here suggest anything bigger than 100 nanofarads to 20 microfarads, and I happen to have a little 10 microfarad cap here, so we're going to put it in. Oh, come on. Still doing thinking. Version 1.12K, which is actually, I think, the latest official release. So it's not bad. That's pretty recent in terms of that. And a 10.2 nanofarad, a 0.02 ohm ESR. I expect that out of this nice multi-layer ceramics. These are really nice capacitors. 0.6% V loss. I'm not sure how accurate that is, but it's actually doing a continuous test, because I think I did see the capacity. Yeah, the capacitance is changing just a little bit, so it's still doing continuous testing. But freaking awesome. Okay, so that's a nice capacitance test. Let's take that guy out. Now we're looks apparently self-tested. Let's try something simple. Where's the resistor? This is supposed to be a 470 ohm resistor. So you're supposed to be able to just jam it in any two components. And push a button. Resistance with an inductance, but it just says it's resistance. 460.5 ohms. So that's really not bad at all. That's pretty freaking awesome. Okay, let's try an LED here. Oh, this sucks. Yeah, that sucks. Let's do an LED and see what it does. I don't know if it'll actually be able to see. Oh, yeah, it actually does get enough voltage to actually flash that LED. So it shows it as a diode with a 1.9 volt forward breakdown. Yeah, with a nice little 5 picofarad capacitance. Okay, let's try nice little diode. I think this is actually 4148, so these are a fast. I think these are a fast diode. It just needs to be a little. I just need to cut out that, and I think this will be better. Oh, push a button. So to testing. Diode with a 700 millivolt breakdown. Nice. Okay. Very cool. Let's try this 100 picofarad or 100 nanofarad cap out of the kit that was left over. Let's just jam it in. Oh. Yeah, this is not going to work. I'm going to need to modify this case. Initial button to test. So it does say 100 nanofarad, 2.8 ohm ESR. It's kind of surprising. Yes, well, that's okay. Let's try something big. Let's try this monster now. They're very adamant about if you try and test something big like a giant electrolytic, is to make sure that it is discharged. Otherwise, it will do nasty things to the device. So let's there we are. Big cap. This is what are these? 100 microfarad. Oh, close enough. Yeah. Big electrolytic. It's big. That's all you need to know. At least it gives you a nice ESR already built in, so pretty positive this is not in a low ESR anyways. It's just a El Cheapo bulk capacitor. Now let's throw something a little bit different. Let's try, this is a quad 2 BJT transistor, so let's see if it gives me something nice. And that is freaking awesome, because it actually tells you the various parameters of the transistor, and then also it automatically tells you what the emitter, base, and collector are for it, and even gives you a little diagram for the circuit diagram, because I always get these freaking wrong. And there's a couple of these things you can't rely on the shape of the transistor. It varies by part exactly which is the emitter, base, and collector, depending on which one you're looking at. So that is super, super handy when that does work. Now let's throw something even more strange. These are 10 microhenry inductor. So we'll see if this can give me an actual inductance on it or not. The inductors are always a little bit of a pain in the neck to figure out, because the color code, I mean, they look like a resistor in the same package, but the color code you have to kind of interpret. Should it be a resistor, or is it an inductor? Is it only a 4-band resistor, or is it an actual inductor? So we'll see what this thing comes up with. Yeah. 0.01 microhenry. That's weird, because my... Oh, yeah, 0.01 millihenry, which is 10 microhenry. No, freaking awesome. Dead on. That's really, really awesome. Sweet. And this is another ceramic cap. This is what size is this thing? This is a 0.1 farad, so this would probably just be a probably register as 100 nanofarad, but we'll see. $75 nanofarad, yeah. 80, 82, weird, climbing. 84, 85. Not sure the exact specifications of this guy. He's a 50 volt Zycon ceramic disc capacitor. So I mean, it's pretty generic, but it's actually weird. Okay, so once it probably gets ESR, it's probably done enough, because it has to probably, maybe it's averaging samples as it's going. So this might actually eventually climb up to 100 nanofarad and then just sit there. It depends on the frequency response, because I'm not sure what frequency this tester is running at in order to determine what the capacitance is. That kind of can greatly determine what its measured value is. All right, now the only last thing I wanted to try is, because it had a really weird mode. There's a couple weird modes on this thing. It's not just a component tester. It can actually do a whole bunch of other smart, weird stuff. So let's, it can do digital thermometers, a 1-wire COM protocol, which is interesting. I don't have any of those. But it can also do, let's see if we can try this. This is one of the more weird modes. It can do a DHT 11, which is a humidity temperature sensor, and it has a 1-wire communication protocol as well. And I've used these before, directly bit banging into it, so it's a little bit of a pain in the neck to try and actually get it to work. But let's supposedly we should be able to do that. Let's see. When you enter this function, okay, so what we have to do is go into the actual menus. So supposedly, I think if you hit and hold this guy for long enough, yeah, okay. Transistor, frequency, function generator. Okay, yeah, because we haven't even hit to this stuff yet, where you can actually do limited function generation with this stuff. A 10-bit pulse width modulation. So I'm not sure what you would be even testing with this. They have an explicit capacitor ESR meter, running from just test points 1 to 3. An inductor tester, so if you have a maybe a high resistance inductor that very large, something like that, and it just confuses the auto tester, you can explicitly go in and say, this is an inductor, tell me what it is. Explicit capacitance tester, DS188B, that must be the temperature sensor, I think, and capacitor with the microfarad correction. IR decoder, IR encoder, DHT11. Okay, so we enter this function. The row 2 of the LCD is showing blah blah blah. Let's see. Voltage 1 should be ground. Pin or test 1 should be ground. Test 2 should be the data. I'm sorry, I'm reading the instructions here, which are kind of crappy English. And test 3 should be VCC. So this is VCC on the left. That means you have to test it like this. And you want to ignore this one since that's a no connect. So you're going to want to do it like, oops, like this, I think. So if we do a DHT11, well, maybe this is backwards. So I tried poking at it, and no, I was connecting it correctly, but even my other spares just simply won't work. These are DHT22s. They should have the same protocol and stuff. They should just be differ by accuracy, but it doesn't seem to give me anything except reading 0 degrees and 0% humidity, which is not correct. So whatever. That's just a weird feature that's not really the primary purpose of this thing. So then it has a standard self-test menu. Then you can go explicitly into the voltage reading in the front. You can change the colors. Let's see, what's this show data? 1.12 with its calibration values and other calibration values. Looks like it's oh, and it gives us some pictures. So BJT NPNs, PMPs, JFETs, which I don't have any of those. That'd be nice to test. IGBTs. Those are a little bit oddball. PMOS and NMOS. Oh, DMOS and EMOS. And all the other various symbols. And a printout of all the selected characters and stuff. Show data, switch off. Okay, now this is wrapping back around. Transistor, frequency, function generator. So I mean, it's pretty freaking powerful what it can do. This is definitely something I'll keep around on the bench, because if I get some kind of threaded component, if I have, you know, like a pile of resistors and I can never remember the color codes, and then they have 3 and 4 band color codes, and never mind. Nope, don't have the time. I can just whack them into this and test them as long as I fix this frickin' case, because this lever being this small just will not work. So I guess I'm gonna have to take this back apart and probably just cut out clean across here, and probably this side panel here to make this finger notch be actually big enough for a finger. I don't know. I can't even fit my pinky in this. But alright. Anyways, pretty neat device. Very, very neat. Very powerful.